Hello friends, welcome to my channel. In this video I will cover production questions. Most of the questions they are from Isro Technical Assistant 2016 and IAS question also I will solve. These are very important for upcoming RINL MT and Isro exams. This is part 8. This is IAS question. In manual arc welding, the equipment should have dropping characteristic in order to maintain dropping characteristic. We know in manual arc welding it's difficult to maintain the gap between the electrode and the workpiece. So we are using constant current and constant voltage. Here we are using for DC welding. In MIG welding we are using constant voltage type and constant current type. This is for manual welding. So B is our answer. This is very important. Both for DC welding or MIG welding we are using constant voltage type, or automatic welding constant voltage type we are using, and manual welding constant current type we are using. Question is, oxyacetylene reducing flame is used while carrying out the welding in reducing flame. We know reducing flame also we can call it as carburizing flame. Here ratio is oxygen to C2H2 ratio is 2:3. This is carburizing flame, and 1:1 its ratio in neutral flame. In oxidizing flame, more oxygen we are using and acetylene less, 3:2 ratio. This is for oxidizing flame. Oxidizing flame, this is neutral flame. These ratios are also important. In carburizing flame it's 2:3, in neutral flame it's 1:1, and in oxidizing flame it's 3:2. And examples for which material welding we are using, that is also very important. Carburizing flame we are using for high carbon steel, aluminum and nickel, and neutral flame we are using for cast iron, mild steel, low carbon steel. And oxidizing flame we are using copper, brass, bronze and zinc based alloy. This one already asked in Isro paper. So from our option, reducing flame or carburizing flame we are using for high carbon steel. B is our answer. And mild steel and grey cast iron both are neutral flame. Then electron beam welding, it can be carried out in open air, no. A shielded gas environment, yes. No, shielded gas environment also we are not using. A pressurized inert gas chamber, no. Vacuum we are using. Electron beam welding, vacuum we are using. In DC welding, the straight polarity or electrode positive. Here in this question, some printing mistake is there. In straight polarity, electrode should be negative, and workpiece it should be at positive. Straight polarity, positive terminal is at workpiece, negative terminal this is for electrode. This is less deposition is less, but more penetration, because maximum heat at positive terminal or positive terminal at workpiece, so more penetration. And in case of reverse polarity, workpiece is at negative and positive it's at electrode, so more deposition and less penetration. All are important. Straight polarity also they may ask, and reverse polarity also. These two conditions also they may ask. Here also two conditions. So in this question, DC welding straight polarity or electrode negative, straight polarity, more penetration and less deposition. So less deposition, B is our answer. This is from Isro Technical Assistant 2016 question. Annealing, nitriding, normalizing and Marr tempering and leads to refines grain structure, improves hardness of whole mass, then improves ductility, increases surface hardness. We know nitriding, it's a surface hardening treatment. So B with IV. You can cut A, we can cut B with 2, so you cut A. Then annealing, normalizing refines grain structure, C with 1, C with 1, so you can cut D and C also. Only B is your correct option. So you can cross check also. Annealing with triple I improves ductility, correct. Then B with IV, correct. Then C normalizing with refines grain structure, yes, correct. Then Marr tempering improves hardness of the whole mass, yes. B is your answer. Tempering of quenched martensite steel is necessary to improve A. Hardness, B. Corrosion resistance, C. Ductility, D. Strength. So tempering we are doing. From austenite, if you do hardening, we will get martensite. Then again reheating and cooling, we will do tempering. In tempering we reduces hardness, then relieves residual stress, improves ductility, improves toughness. If you increase ductility, automatically toughness will increase. Then reduces hardness. So from option, it improves ductility. Same question already discussed. In IES also they are same question. Which of the following welding techniques requires a vacuum environment? It's electron beam welding. Already discussed. This one also already asked in IES. Allowance provided to vertical walls of patterns for easy withdrawal is called. It's draft allowance. This question was from Isro Technical Assistant. Also same question asked in ONGC Management Trainee paper. In milling machine, cutting tool is held position by, this is by arbor. Here this type of question in IES also get in, they are asking this type of, Isro scientists also they are asking this type of question. In an interchangeable assembly, shaft size given, are meted with holes of size, hole size also given with tolerance, maximum interference and maximum clearance is respectively. Maximum interference and maximum clearance. So basic size given, it's 30. We will start from basic size. First draw the line for basic size. Let this line represents basic size or zero line. Basic line or zero line. Its dimension is 30.00. Then from hole we will start, or shaft size given first. So from shaft we will start. Shaft maximum size is 30 plus 0.030. So right shaft, then it's minus, so this point is 30.030. This is 30 minus 0.01. So you will get, it's 29.99 mm. This is minimum limit of shaft, and 30.030 it's maximum limit of shaft. Then for hole we have to write, for hole dimensions are all are positive. So 30.020, first it will get minimum diameter of shaft start from 30. This distance is 0.02. You will get 30.02. Then maximum hole diameter it's same as shaft maximum, so 30.03. This is hole. Blue color it represents hole and black color it represents shaft. Then in this question we have to check maximum interference. Maximum interference is here. The difference between hole minimum and shaft maximum. Hole minimum is this one, shaft maximum is this one. Diameter, minimum diameter of hole and maximum diameter of shaft, this difference. This is maximum interference. So you have to subtract this one, 30.02, you will get 0.01. So from option it's in mm, 0.01, so 10 micron. 10 micron is maximum interference. So you can answer A. Or second one also you can check maximum clearance. Maximum clearance is this one, shaft minimum and maximum diameter of hole, this distance. So you have to go 30.03 minus 29.99. You will get 0.04 mm. So 40 micron. Same answer we are getting. So option A is our answer. Here this is hole tolerance, this one, and shaft tolerance is from here to here. This is also very important. And 0.02, this is fundamental deviation of hole, minimum distance from basic line. This type of list 1 and list 2 matching already discussed in IAS question papers. Defect and cause. Holding defects are sputter, lack of penetration, slag inclusion, porosity. Porosity we know for damped electrodes. Then slag inclusions also improper cleaning. So C with IV, D with 1. C with IV, D with 1. C with, you can cut this one, then you can cut B also. Then sputter. Sputter is arc flow. A with 3, B with 2. Answer is A. This is end of part 7 or part 8 I think. Part 8 I think. Next question or not I will solve in other videos. Thank you friends. Thank you for watching my video. Thank you.